Hi, ma'am. Um, Matter and energy. Matter is anything that has mass and takes up space like solids, liquids, and gases. Energy, on the other hand, is the ability to do work or cause change. They're interconnected through Einstein's famous equation, which shows that energy E is equivalent to mass times the speed of light squared. In simpler terms, matter can be converted into energy and vice versa. For pure substance, a pure substance is a material with a definite composition and distinct properties. It can be either an element made up of an identical atoms or compound composed of different elements chemically bonded together. Water and oxygen are examples of pure substances. For mixtures, a mixture is a combination of different substances physically mixed together, each retaining its own properties. Unlike pure substances, mixtures can be separated into their individual components through physical methods like filtration or distillation. The air we breathe is a mixture of gases, primarily nitrogen, about 78%, oxygen, about 21%, and trace amounts of other gases like carbon dioxide, argon, and more. This mixture is essential for sustaining life as oxygen is crucial for cellular respiration. For temperature, temperature is a measure of how hot or cold something is. It reflects the average of energy of particles in a substance. When particles move faster, the temperature is higher, and when they move slower, the temperature is lower. We commonly measure temperature using scales like Celsius or Fahrenheit. For elements and symbols, elements are basic substances that cannot be broken down into simpler substances by chemical means. Each element is represented by a chemical symbol, typically one or two letters. For example, H represents hydrogen and O represents oxygen. These symbols are used in the periodic table to organize and categorize elements based on their properties. For atoms and elements, atoms are the smallest units of an element, and elements are substances made up of identical atoms. Each element is represented by a unique chemical symbol, like H for hydrogen or O for oxygen. The combination of different types of atoms creates various elements, and these elements make up everything in the universe. The periodic table organizes these elements based on their properties and atomic structures. For metals, nonmetals, and metalloids, metals are elements characterized by their conductivity, malleability, and luster. Nonmetals are elements that generally lack the properties of metals. They are typically poor conductors of heat and electricity and may exist in various states at room temperature. And metalloids are properties intermediate between metals and nonmetals. They exhibit a mix of characteristics such as a semiconductivity for atoms. Atoms are the basic building block of matter, consisting of a nucleus containing protons and neutrons, with electrons orbiting the nucleus. Elements are composed of unique arrangements of these atoms. The number of protons determines an element's identity, and atoms are electrically neutral with the number of protons equaling the number of electrons. For isotopes and atomic mass, isotopes are variations of an element with the same number of protons but different numbers of neutrons in their atomic nuclei. This results in isotopes having slightly different atomic masses. Atomic mass is the average mass of all the isotopes of an element, taking into account their relative abundance. It is usually expressed in atomic mass units. For electron energy levels, electron energy levels are specific orbits or shells around an atomic nucleus where electrons can exist. These levels are quantized, meaning electrons can only occupy certain energy levels, not anywhere in between. Electron energy levels can change in certain situations, typically through the absorption of or release of energy. Our absorption energy and emission energy. Chemistry is the study of matter, its properties, composition, and the changes it undergoes. It explores the interactions between atoms and molecules, helping us understand everything from the structure of substances to the reaction that form new compounds. Chemistry plays a crucial role in diverse areas from medicine and material science to environmental studies. And that's it, ma'am, and thank you po.